The last method of pricing is the demand-based pricing. It's the last part of the chapter. Demand-based pricing. What we are saying here is that we're going to use our demand understanding to determine how our pricing should be. Should we be increasing our pricing, or should we make it constant, stable, or should we be decreasing it? How should we manage our pricing based on the understanding of our demand rule? What is demand law? The popular demand law is that when you increase price, what happens to demand?
So demand decreases.
Exactly. If you increase the price, the demand will decrease because people will run away from high price. So which means the price is inversely proportional to demand. If you lower the price, a lot of people will come. That's why you do proportional sales. So it's always on, remember, it's pricing that we are looking at. This topic is all about pricing. We've spoken about the first method, which is cost plus. The second method is market-based. We've looked at it. The third one is what we are looking at, which is demand-based. So we want to see how can we determine appropriate price using the understanding of our demand relationship with price. So since we know that, that means that looking at the graph, if we put price on y-axis, quantity on x-axis as usual, we expect the graph, demand graph, to be like this. You remember very well, it's always a negative slope. Yeah, and that is why in equation, what's the equation of a straight line? Who remembers equation of a straight line? Any straight line. Why?
B
equals mx plus c.
Yeah, something x.
Thank you.
Yeah.
Any straight line, that's the equation of a straight line. Y equals to mx plus c. Y is your y-axis, m is your slope, x is your x-axis, and c is your intercept on y-axis. Right. So this equation, we will be using it here. That equation of a straight line, because it's similar and same thing that we're going to apply for this demand graph. So because what we are saying is that y is our price. So price equals to the slope, x is our quantity, and c is the intercept that we don't know. But one thing you need to realize that because the negative slope graph, m will be negative. Because if it was a graph that is upward sloping, something like this, then the slope will be positive. This is the equation. So which means it's just easier to just write it as C minus MQ. Yeah, that is better. Easier to operate like that. So this is your popular demand function, where P is price, C is your intercept, M is your gradient, which is also called slope. Yeah, so M is your gradient. Another name for it is slope. C is intercept. Yeah, and you know your P is price and Q is quantity. So take for instance, if I say company A is able to sell 25,000 units at $20. Yeah. However, if it increases, if it's had to increase price to $24, company A will sell 23,000 units. What's the demand function? That's the equation. Remember, what has happened here is you just put it on the table like this and you say price and quantity. When price was $20, we're selling 25K. If you increase it to 24, quantity will drop, which is what we expect from a typical demand law. Yeah, that's what we expect. So for us to be able to write this equation properly for this scenario, we need to first calculate our gradient. Yeah, which gradient is your y-axis divided by change in y-axis divided by change in x-axis. And change in y is, you can say, is P2 because it's price. Y-axis is price. So it's the second price minus first price divided by second quantity minus first quantity. So the second price is 24. So that equals to 24. And the second quantity is 23,000, 23K minus first price of $20 and 25K as the first quantity. And that will give us 4 over 2,000. 0.0, another one. Yeah. Let me use calculator. 4 divided by 2K. Let me not stretch.
0.002.
Thank you. 2. Yeah. So that's our M. That's the slope. So we know slope. Yeah. Which is this M. Now we need to know our C. Please follow me closely. And to know our C, all we need to do is to take either this first scenario or the second scenario to calculate C. Because from first scenario, we know our price, we know our quantity, and now we know the slope. So we can get the C. So we know that the general formula is that P equals to C minus MQ. And which scenario do you want to pick? First one or the second one? Let's pick the first one. Price is $20 equals to C that we want to calculate minus 0.02. And the quantity at that price was 25,000. So which means 20 equals to C minus, what is that? 0.02, that's 50. Yeah, thank you. And C equals to 20 plus 50, which equals to $70. So that is C. So now that we know the C, we can write a full demand equation, which says that P equals to 70 minus 0.002 Q. So that is demand function. But it's also important to be able to determine the revenue function. Revenue function. This is, if this is price, remember this is price. How again do you get your revenue? If you know your price, what do you need to do to price to get revenue?
Multiply by quantity.
Exactly. You multiply by quantity. So which means that equation we have to multiply by the quantity, right? So which means P equals to 70 minus 0.002 Q is the price. So this, to get revenue will be equals to 70 minus 0.002 Q, then this multiplied by Q again. And if you need to open this bracket up, then revenue will be equals to 70Q. Sorry, yeah, 70Q minus 0.002 Q square. But don't be afraid. You would never have to use this formula. What you need to understand is that marginal revenue will be extremely important for us. So this is revenue, but what we need to know is marginal revenue. And what is marginal revenue? Marginal revenue is the extra revenue from one extra unit. The extra revenue from one extra unit. Just think of like marginal cost. Extra cost from extra units. Marginal revenue is also extra revenue from extra units. And you will see where this will be important. But before we get there, I just want to use this opportunity to explain that the formula for marginal revenue is what you always need. Yeah. And the way that has been derived is calculus. Yeah. So remember we said P is this, C minus MQ. So marginal revenue will be C minus 2MQ. That's the only formula that you need to memorize. I could have shown you how to get it, but if you have never done calculus before, it's just a waste of time, man. So C minus 2MQ. This is the formula for marginal revenue. You can see the only difference is just that this revenue formula is what was changed to this actually by differentiating it. But don't worry about yourself. That's a calculus workings, which you don't need to know. But you need to memorize this formula then, since you can't derive it, because you always need this marginal revenue formula, and you will see where we will need it. Right? So now we got the demand function here. Price equals to 70 minus 0.002. Why is it important? Why do we need demand equation? We're interested in pricing, remember. So, which means that we need to know the effect of changes in pricing on the quantity. Yeah, and ultimately on revenue and profit. And you will see that. Yeah, because we said that if we increase the price, what happens to demand? It will drop. If we reduce the price, the quantity will increase. So we need to know what direction should we take. Should we not even touch the price? Should we increase the price or should we decrease the price? We need to know. And the only way we can know is through what we call price elasticity of demand. This will give us a lot of insights as to how should we manage our changes in price. Because if we understand the price elasticity of our products, we will understand how changes in pricing will affect the customer's demand for that product. So which means we need to understand price elasticity of demand. And how do you calculate price elasticity of demand? That is equals to your percentage change in quantity divided by percentage change in price, because it's when you are changing the price that the quantity is changing. So always know that price is under. Yeah. Obviously, this will always give you a negative answer, but the negative figure is always ignored. Negative is coming from the negative slope. So you ignore it when you are calculating elasticity. Yeah. And there are 5 types of elasticity you can have. There are 5 different groups of products. Yeah. That can have that. I will try and see if I can summarize it in a short table. So 1, 2, 3, 4. Yeah. 5 we can have. So we get a price elasticity of demand. What can be the meaning? Let me see. Can I plot the graph as well for you? Let's see if we can do the graphing. Yeah. So if I'm going to do the graph, I won't be able to, it won't be this close, right? Okay, so the first one is when you have price elasticity of demand that is greater than 1. And when it is greater than 1, then that product is said to have an elastic price elasticity. So you said that product is elastic. And what does it mean to be elastic? If you look at this formula, it's elastic because anytime you change the price, you're going to experience even higher change in quantity. So what we are saying here is that percentage change in quantity is always greater than percentage change in price. That is why it's greater than 1. And such products are called elastic. So what we are saying is that you touch the price, the quantity will suffer or will move, to put it like that. So if you increase the price a little, what happened to the quantity demanded? It means it's going to drop drastically. It's going to drop a lot more than the increase. Likewise, if you reduce the price, the quantity that you will sell will go up a lot. So quantity is responding much more than the pricing. And let me see if I can do a graph like that. The same price and quantity. So if price changes a little, no, this is not showing it very well. Should be flatter. Yeah. So I imagine you have just a price from here to here. See how much the quantity has changed from here to this place. See the short distance of pricing. See the long distance of quantity change. So obviously, this will give you a greater than 1 elasticity. And what kind of product will behave like this? That you just increase the price a lot, people are running away from the product. It has to be luxury product because it's non-essential. Think about it, flight ticket. If flight ticket becomes expensive today, there are a lot of vacations that people will just drop it. Yeah, they won't go. Because it's not essential, it's not compulsory that they have to spend that money. So if you increase the price too much, the quantity will change even much more. Right? So in that case, you have to be careful with this type of product when you want to change the price, when you want to determine what price should I be charging. Because it's an elastic product. The product is so sensitive to price. But let's look at the other one, which is a situation whereby the price elasticity of demand is less than 1. And in that case, we say this is inelastic. And what does it mean to be inelastic? You are saying that even when the price is changing, the quantity is not really changing. What kind of product do you think will behave like that? So where the percentage change in quantity is much less than the percentage change in price. You are increasing price by even 40%, maybe just 1% change in quantity. What kind of product will behave like that? Let's draw the graph. So it's going to be almost like this. Yeah. So that if you move from here, see, look at the short distance for the quantity, for this, for price. This will be essential products that people naturally cannot do without. Maybe you're talking of medication. I mean, if you have to take medication, you have to take it. You won't, I don't know how many people will check the price of medication. Right? You just have to buy. Or even gas. If you have a car, no matter the price of gas, you have to buy. Utility, generally. You want power, you want everything. No matter the price, you need water. Let's go to the next one. We said there are 5 of them we want to touch quickly. The third one is when you have price elasticity, that is 1. And that is called unitary elastic. Unitary. Anything unitary is 1. Units. Yeah. Unitary elastic. If you're saying unitary elastic, it means that the change in price is the same thing as change in quantity. So which means it's rare. I mean, you hardly see a situation like that is proportionate. It's the same thing. Yeah. But it's possible that if you change the price, the percentage at which you change the price, the same percentage at which the quantity will change. Yeah, maybe clothing might behave like this. Because you still need clothing, right? Right? But at the same time, you don't want it to be too expensive. So there's likelihood that you might say, I will manage what I have for now, but there's an extent to which you cannot manage it, that you still have to buy. So I'll put clothing in that kind of space, then maybe even going to cinema. Something like that. You still need to go to the cinema, but if the price is too high, you might slow down a bit, but you still go. Because you have to go. Yeah, it's part of living, you know. The fourth one is when it's equals to 0. And when it is 0, you say this one is just perfectly inelastic. And if it's perfectly inelastic, you are saying that no matter how you change the price, the quantity would not change. So something like this. So if this is price and this is quantity, price is changing, but the quantity stays on the same spot. Can you think of any products? I'm just thinking that might actually act like this. Is also rare for sure. You hardly find product behaving like this. But what kind of products will you be changing price like that? And okay, maybe chemotherapy. For people that have cancer, no matter the price of this, it doesn't reduce the dosage. They still have to take what they have to take. If they have to do GoFundMe or something, they need to buy it. Yeah, I can put that there. And the last one is when the price elasticity of demand is infinity. Yeah, and in that case, you say this is perfectly elastic. So which means before you even try to change the price, the quantity is changing already, like something like this. So the change in price is so small that you can't even see it, but see how the quantity has gone out of sight. Yeah, it's also rare, but maybe substitute products will behave like this, where just a slight change in the price, the whole product is neglected and people move to something else. Maybe if you think about Uber or on boat or Lyft. If Uber is more expensive, I have people that before they book Uber or boat, they will check both prices and they go for the cheaper one. Yeah. Or you have butter or margarine. If one is more expensive, people will go for the other one and neglect the other one because both of them will give you the same satisfaction. Right. So in that case, price is extremely sensitive. Yeah, so quantity rather is extremely sensitive. To change in price. So, and how does that understanding help you? It is going to help you because if you have elastic product, you know you can't just charge price as you like it, or you have a perfectly elastic product, you can't charge price as you like it. You have to be cautious. You have to be careful. That is why the understanding of the elasticity will help you. But if you have inelastic products, all day, enjoy. Keep increasing the price. You will always sell. So that is the understanding that you will use to get the right pricing and not price yourself out of the market.